Ladies and gentlemen, please welcome to the stage a representative from Windsurf.
All right. Well, first session of the day. So thanks everyone for being here. It's gonna be a good one. So I'm Anshul. I'm part of the founding team of a company called Windsurf. The very short TLDR is that we build AI for software engineering. So the entire idea of software, the digital fabric being super important to national security and our interests as a country, we want to make sure that we can build the most secure, help our federal government secure that, continue to develop, and kind of push kind of our digital fabric forward. And so today, really, in these 15 or so minutes, kind of want to show you one of our most recent developments, which is our own kind of family of large language models, which we call SWE-1. So that stands for Software Engineering 1. So these are models built entirely in the US, particularly for the task of software engineering, right? So if you ask, how many people here are software engineers? Just as a raise of hand. Okay, so a handful in the audience. For anyone who's a software engineer, you'll know that there's a lot of different tasks that you have to do as an engineer. It's not just the process of writing code. For most people who aren't software engineers, they think, okay, software engineering, that means you write some code and it's over. There's really actually quite a lot that happens behind the scenes. To write code, especially mission critical code, it is important to understand legacy systems that exist in our federal government. It's important to write the code. It's important to modernize your stacks, right? There's a whole set of different tasks that we have to do to make sure that we are shipping code that is secure and can actually solve the tasks that we were meant to solve. And so what I'm going to show today is I'm going to show a number of kind of examples of what these models that we've built can actually help complete for a software engineer. So over here on the screen is our primary tool. It's called the Windsurf editor. You can kind of think about it as like a workbench for a software engineer, where a software engineer spends a lot of their time writing code, reviewing code, iterating on code, things like that sorts. And what you see here on the right is a chat-like panel that is not too dissimilar from something like a ChatGPT. Who here has tried ChatGPT? Okay, I think there are more hands this time. That makes sense. Now, when you ask ChatGPT a question, right, you ask a question, you get a response back. That's the kind of interaction modality, right? You ask one question, you get one question back. There's not really any action being taken, right? The AI itself is just giving responses. It's a bot, right? It's like a chat bot. What we've done is we've essentially brought that same kind of interface, this chat-like interface, into the workbench where software developers complete their work. And by integrating our models, we actually let our models take action. So they're allowed to go and investigate code by itself. They're able to run commands by themselves. They're able to make changes to the code base themselves. And so we'll try a few of those tasks ourselves. So our agent's name is Cascade. That's what we call it. Windsurf Cascade. You can kind of get a little bit of the aquatic theme going on here. And I currently have the SWE-1 model selected to be used. And the first thing I'm going to do is in this code base, you don't need to know what this code does. It's some 100,000 lines of legacy Java code. If you ask any software engineer how long it will take to understand 100,000 lines of legacy Java code, they will say you somewhere in the order of a couple months, 2 to 3 months, right? So it's a good amount of code. Imagine, you're reading a pretty complex book that in a language that you're not very familiar with, right? That's kind of the levels of what we're talking about. But I'm going to just ask Cascade, what does the code in, and I'm just going to tag the entire repository, so the entire set of code. I'm just going to ask what it does. Really simple question, right? And the beauty of having the kind of agent live in the workbench where all the code is and where the developer does its work is that it can actually access all that information, right? So we've now built a system that can understand software engineering, can understand code, and can now actually take actions by itself. So as I'm talking, it's going through and it's taking multiple actions to look through the directory structure. How are all these files organized? What is the structure of this? What are some of the main, pieces of code that probably are relevant? And after that, it will start kind of, describing exactly kind of what this repository does. So a task that would have taken about a couple of months, we already have a high level in about 30 seconds, right? So this is kind of the rate at which AI and models like SWE-1, which are trained for the tasks of software engineering, are capable of doing. We can, follow up, right? It's asking me a question, would I would like to explore any specific part of the code base in more detail. let's take a look. There's some key features. How about let's ask, how does the book catalog management work? So I can ask follow-up questions. So instead of knowledge being in a bunch of different disparate sources and different people knowing different parts of code, what we're able to do now with AI is allow individual developers to go in and introspect code by themselves, ask questions, the second-order questions, third-order questions by themselves, and quickly learn these legacy code bases that would have taken most developers months to do, even the best ones. And as it does its work, we built a system that's very human in the loop. So this is not an AI agent running out like a mock doing a bunch of changes that we don't understand. Everything is kind of cited. So I can cite my sources. I can kind of look at what the AI is looking at and understand myself what's going on. Right. So here we kind of did a deep dive into things. That's kind of just working with an agent in the chat. And we'll do a few more things with the agent in the chat, but there's a lot of other things that we built to help accelerate software development as we know it. One of the things that we built is just tools that you probably actually have noticed when you write an email or you write a text message. Simple things like an autocomplete functionality. So what I'm going to do is I'm actually going to open up a file. And there's a file here. It looks good. But I might want to add some more stuff to this. Like let's say I want to go in and I want to start typing. You can see over here that the AI is actually suggesting code for me in kind of like ghost text. A lot of the work that software developers do to be able to interface with machines is to write what we call a lot of boilerplate code. These are just like scaffolding code just so that the machine that understands everything in zeros and ones and the human, which understands everything in English, are actually communicating. Right? There has to be some structure of code. It's not as clean or like free-flowing as like normal natural language English would be. Code has to be structured. And so similar to kind of how while you're writing an email, you might get an autocomplete suggestion in your Gmail to kind of finish your next lines, we've built those same kind of functionalities using the Sui 1 models to do that same thing for code. So here, I've actually not typed anything about this book type. That's actually all being suggested by the AI. And all I have to do is like press the tab key to kind of accept that suggestion. I'll actually close this for now just for visibility. And I can go in and I can start modifying different parts of the code base. Right? I added the book type over here. I can go in and you'll start seeing that the tool will keep on suggesting the next changes I need to make. So all I'm doing is keep on pressing the tab key and I've just keep on writing code. Because what we've been able to do is have the AI, again, understand the code that already exists and therefore help accelerate developers through that kind of menial stuff that is just there to communicate with the computer, as opposed to what are the actual changes in the mission that I'm trying to complete, and what do I therefore need to build in order to complete that. So there's all these kind of tasks that we can do. I'm going to show a few more things, a couple more demos. So I'll go back to Cascade. It's really important when we're developing software over multiple decades, as we have in the federal government, in order to have code that is really well documented. It's very important for that to be the case because, as I said, a lot of how code is written, unless you're a software developer, all of this probably looks like nonsense, for lack of better words. Right? It doesn't read like normal English. It's all there. It does the task that's meant to do, but it's not human legible. Right? What we want to make sure is we can leave documentation within the code to explain to the next developer that has to work on this code exactly what does this code do, right, in natural language. That's the process of documentation. It's incredibly important to do. It's also very, very boring. If you ask any developer, like, hey, do you want to write a bunch of documentation today? They will rather call in sick. So it's a really important thing to do, but very, very few people do it. So the beauty of an AI is that an AI doesn't have that kind of emotion. Right? It's like you tell it to write some documentation, it'll write documentation. Right? It has nothing really better to do. So what we'll do here is we'll kind of look at some code here. Okay, so I found some code over here. These look like a bunch of tests to me, but there's no documentation on any of these things. Right? It's just a bunch of code, no documentation anywhere. So what I'm actually going to do is I'm going to go to Cascade, and I'm just going to ask Cascade, add documentation to all of the tests in, and I'll just tag this entire directory called integration test. So I just want to add documentation to all of these things. And so, as it's going out there and it's doing some work, the beauty of, having the AI kind of live in the workbench of a developer is that instead of just being able to answer questions like you would with a ChatGPT, it can actually take action by itself. So it can actually even propose changes to the code, right? So not only is it giving you a response of like, oh, here's how your code should look, it's actually going to take that code change, insert it into the code base, and allow the human to review that code, whether or not they actually want to commit it and merge it into whatever like the golden set of code actually exists. So it's kind of going in there, and you can already start seeing it's analyzed, some of the files, some of the tests, understands what's going on, right? It's not just going in and making changes without understanding first what the current state of the world is. And then it's going to go and it's going to start making some edits. It's taking longer than expected because I'm on conference Wi-Fi. I blame it on conference Wi-Fi. While it's working, I'll just talk a little bit more about SWE1 in general. So we're a company that's based out in the Bay Area, and one of the things that we've done is we built this platform, Windsurf, that has over 1 million active users today. So over 1 million developers currently use the tool, and so we're able to really quite quickly see what are the steps that developers take in their day-to-day. How do they actually go about doing their work? It's from those signals and those kind of learnings that we can take that kind of information and use that to fine-tune and train further models with kind of information that other parties and entities and potential adversaries don't have. And so that's why we'll be able to make these kind of frontier models specific to software engineering, right? So just as part of kind of the history of how we're able to get here. So as we're going, it's going to keep on going. It's going to add more tests, but you can kind of already see, right? For this file over here, it's added some 70 odd lines of documentation across this file. And as a developer, I can go in, I can kind of review these changes, I can accept them. We're still very human in the loop. Again, we're not in the business of having AI run around making a bunch of changes to code and no one knowing what's going on, right? It's all very human in the loop. The developer has to go in and actually accept those changes. But kind of already, while we're just chatting, I can ask Cascade to start doing some work, and I can go grab a coffee, and I can come back, and it's going to have documentation written across multiple files, right? So already it's gone to the next file. It's added another 25 odd lines of documentation here. So if you kind of just back up for a second, right? In a few minutes, the AI went in. It just took a simple command of add documentation. It went in. It understood what all the code was doing, right? What was actually happening, right? And code is a very disconnected knowledge source. There's lots of files that affect how a particular block of code would run. It understands what's going on. It then goes to the file. It adds documentation that's contextually relevant, inserts them into the code base in the right places, and then moves on and just keeps on iterating, right? All of that happening in a few minutes. Again, a task like this, you ask a developer to do, if you can find a developer to do this task in the first place, it would probably take them on the order of hours, right? So, I'm just going to back up because I think, I've got like a few more minutes left here. These are just a few examples of things that people are able to do with SWE1. We have had everyone from researchers at our national labs iterate on, cutting-edge science. We've had folks in the Department of Defense help kind of strengthen their legacy systems. We work with some of the largest commercial companies, from the biggest banks to the biggest healthcare companies. And we're now living in kind of an era where things like this weren't even possible 6 months ago, right? The technology has improved to the point where the rate at which we can iterate and strengthen our digital fabric is a rate that, frankly, we've never really seen before, right? And so we're really excited to be FedRAMP High authorized, IL5 authorized, to be able to work with the various agencies and departments of defense, because this is the new frontier, and this is the new era of possibility. And the thing I always say at any of these talks is that today is the worst the technology is ever going to be, right? It's only going to get better from here, and what's going to be possible is going to be even more important. So it's important for us as a country, as a nation, to kind of really adopt this quickly and keep moving forward. So with that, I think my time is pretty much up. So appreciate you all listening. Enjoy the rest of your day.